Hi, I'm Sarah, and today I'm going to talk about integrating adaptive navigation into your Jetpack Compose apps. For the past few weeks, I've been building an Android app that allows developers to sign up for my K-Tour API that provides city data. In my last videos, I designed and coded my home screen and account screen, but I only had temporary navigation in place. This week, I finished up the navigation and added support for multiple device types and layouts. In the next slides, I'll go over how my navigation and layout code is structured, then I'll give a quick demo of how it looks on each device. All of the code for this video is out on GitHub in a branch called Adaptive Navigation. I put the link in the description below. To follow along and set up the K-Tour API backend, you may want to check out my previous videos. In my main activity, I check to see if the device is a foldable phone. In this flow, I use the WindowInfoTracker to save the folding features to a data class called FoldableInfo. Next, I use a custom WindowSizeClass function to get the window metrics, get the window size in DP, and call the WindowSizeClass to get the standard window thresholds, which are compact, medium, and expanded. This function is very similar to Android's Calculate Window Size class, with a few added features. In my app, I wanted more than just the width size class and the height size class, so I return a custom data class that also stores the screen size and the current rotation. Next, I use the foldable information and the window size thresholds to create my own layout types. This includes checks for foldables, landscape layouts, and portrait layouts. In this step, I use window size class thresholds along with the window DP size to create my own layout types. These layout types are the final enums that let my composables know how to render the content for each of my routes. They also indicate what type of navigation option to show for each route. Here, my enum class uses the layout type to decide on a navigation drawer, a navigation rail, or a bottom navigation bar. I also have a few convenience functions that group the different layout types into high-level layout grids. Now that my layout types are defined, it's time to render the content. Here, my app root composable creates the background image first. Next, it uses the app layout mode to check if it's a foldable, check for a double panel layout, otherwise it renders a single panel. Once the top-level layout types are determined, AppRoot then calls Use Landscape Layout, Use Double Layout, or Use Single Layout. These functions set up the navigation bars and scaffolds depending on the layout requirements. For example, Double Layout uses a navigation drawer, whereas a landscape layout uses an app navigation rail. The navigation composables have their own files in the presentation folder, making it easy to update each navigation type independently. Each navigation function takes a list of top-level navigation destinations and loops through each to set up the icons and the icon labels. Each function also gets the current route from the current backstack entry and selects the item accordingly. Top-level nav routes are defined in appnavigation.kt. And finally, each route then determines what content to load, including a main panel and a details panel if the screen is split. So what does this look like? I have a couple of devices set up. Let's take a look at the resizable phone first. Portrait phone screens use a bottom navigation bar. Here's the home screen, the account screen, and the search screen. I use K-Tour's HTTP client to bring back a list of cities. I'll go over this more in my next video. When a screen is in portrait mode, clicking on a city takes you to the city detail. This is an example of a sideways phone. The bottom navigation would be too stretched in this mode, so this layout uses a nav rail instead. The main screen allows for scrolling, and the padding is dynamically increased in this mode for a better layout. And here's what it looks like with the list view. In the details view, the city information dynamically splits into a row with 2 columns to fill in the extra space that's available. Finally, split screens use a nav drawer. Users can tap the logo to open it. Even in this very small square, the app still scales and looks good. If a user expands or rotates the split screen, the layout adapts. In this example, the bottom nav bar appears once the height is increased, and the nav drawer is still available if the user flips their phone. Next, I'll show you how this looks on a smaller, narrow tablet. So for these devices, the portrait mode isn't really much wider than a phone that's rotated on its side in landscape mode. For my app, these narrow tablets aren't quite big enough to fit a double layout. So in this mode, I show a nav rail and increase the padding on a single screen. When they're flipped, there's plenty of room for a nav rail and 2 screens now. Here, the nav rail width is increased for bigger screens, along with the side padding. With larger tablets, I have much more room. For widths over 840 dp, WindowSizeClass sets the width to expanded. In my app, I override this and set expanded as over 950 dp instead. For this layout, it's still not quite wide enough for a nav rail on the side. This tablet has a portrait width of 900 dp, and here I'm using a nav drawer instead. The city info has a different layout for double screen modes. My app also adapts to much larger screens. This one is 1280 dp. Here's a split screen on a larger tablet. Only the city detail is currently showing. But what if they switch to full screen? This is not a problem. While it may have looked like a navigation event when the layout was only showing a single panel, both of these screens share the same view model, so the layout is adaptive to configuration changes. Instead of navigating, the content is either hidden or shown based on the current UI state. So when a user changes to a full screen layout, the initial search results are added and maintained. What about foldables? Foldables are really tricky. If it's flat, then my app renders layouts that are similar to tablets. But if it has a hinge, we have more challenging user experience options to consider. Next, I'll show you how I handled tabletop and book postures. So here's a book posture. It's very similar to a tablet. It uses a double layout with a navigation drawer. And here's just a different angle. Now for tabletop views, I went with something very different. Tabletop uses a side nav rail, and the main buttons display in a row instead for easy clickability. Then the details pane moves to the bottom. And this is how the search route looks. The city search results scroll in the top panel, and the city details display in the bottom panel in landscape mode. And if the foldable is closed, it just displays like a standard phone in portrait mode. I still need to experiment with this, and I haven't tested it fully, but I'm happy with these basic layout options. For foldable layouts, first I get the hinge bounds in dp. Then I use these bounds to lay out my scaffold dimensions. I just have one more key point to mention before I wrap things up. For foldables in all layouts, snackbars and scaffolds adjust as needed to make sure that snackbars don't cross over hinges or get cut off. Book postures and layouts will only show messages on one side. That pretty much covers most devices and layout options. With so many layouts to consider, it can be really overwhelming at times, but if we always try to implement good architecture, design modular templates, and utilize the awesome features of Jetpack Compose, then we can ultimately build a solid foundation that works for all of our apps moving forward on any device. Okay, I know I left out wearables. I will get to them one day. Now I'm off to finishing up this app. Thanks for watching.